So sets are very general objects in mathematics. They are not numbers. They can be letters. They can contain other sets. So they are really wild things. So you can't really add them as numbers or multiply them and stuff like that. But there are other operations you can do with sets, and that's what we'll see today. These operations are union, intersection, set difference, symmetric difference, and complement. So let's take the set 1, 2, 3, and let's take T to be 2, 3, 4. And the union is just the collection of elements that belong to either S or T. And it is denoted S capital UT. And this is the okay, and in this case, S union T will be the set 1, 2, 3, and 4. So take the elements of both the sets and just put them together. And remember that we don't repeat elements in a set. So even though 2 occurs in both S and T, we don't write 2 twice. Similarly for 3. The intersection, denoted S U upside down T, is the collection of objects in both S and T. So I'll write this instead as elements in both S and T. And so what are the elements that belong to both S and T? In our case, those are 2 and 3. So S intersection T for us is 2, 3. Set difference. Now this is, it's called difference, but it's slightly different from what we think of when we think of difference of numbers. Okay, so what is set difference? So you can either have S minus T or T minus S. I will talk about S minus T. S minus T is the elements in S that are not in T. In this case, set difference S minus T becomes 1. Similarly, if I were to do T minus S, I will get 4. We have another notion called symmetric difference. This is denoted as S, then plus with a circle around it, and then T. These are the elements which are in S or T, but not both. So this should remind you of exclusive OR. Symmetric difference is like the exclusive OR. So I get the symmetric difference is 1 and 4. The complement. So here I need a subset. So I cannot talk about complement for S and T. If S is a subset of U, the complement of S in U is the elements of U that are not in S. So let's do an example. S, let me keep S to be the same as above. S is 1, 2, 3. And let me take U to be the set of all natural numbers, which start from 0 for us. So 0, 1, 2, 3, 4, and so on. Then the complement denoted S bar is the elements of natural numbers which are not 1, 2, 3. So 0, 4, 5, 6, 7, and so on. That's complement. We have union, intersection, set difference, symmetric difference, and complement. Of these, I would say symmetric difference is not very commonly used. So is set difference. These two are very rare in math. The most commonly used stuff is intersection, union, and complement. So make sure you understand these three really well. Now just one notational thing. There is a way to write unions of multiple sets. This is a notation for that. So suppose I am given a collection. Suppose I given n sets, S1, S2, Sn. Then the notation big U I equals 1 to n Si stands for S1 union, S2 union. And this would be that belong to some SI. And similarly, there is a notation for intersection. And this is collection of objects belonging to all of SI. Finally, let me talk about the Venn diagram. The Venn diagram is a pictorial representation of sets. It is not a precise representation. It is just an approximation, and it is useful for exposition and communication, but you can't use it for doing math or writing proofs. So this is just to simplify all this jargon, okay? But it's a very useful tool. So let me go back to our original example. So I have S is 1, 2, 3, and T is 2, 3, 4. I want to pictorially represent a set. The way I'll do this is I'll use my, I'll denote my elements as points. So I'll just put points like that, 1, 2, 3, and 4. And I'll say, this is my S, and T is 2, 3, 4. So I'll denote sets by regions and elements by points. So now I can describe all the operations using Venn diagrams. So let me make copies of this. So first, let's do union. Union is a collection of objects that are either in S or in T. So 1, 2, 3, 4, all of them. So the union would be this set. Intersection is the set of elements that belong to both S and T. So the intersection is the blue region. Okay, so that is the intersection. Then we have the set differences, S minus T and T minus S. Okay, then we have the symmetric difference and complement. Okay, so that's symmetric difference. And finally, complement. Now, complement I need, for a complement I need a subset. So I'll just create a new one. U, which was the set of natural numbers. Then this is S. And then the complement is nothing but everything that is outside of S. That is my set complement.